Hello everyone, I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to talk about Bayes' theorem, its applications in real time along with its applications. So, coming to Bayes' theorem. So, Bayes' theorem, what is the purpose of Bayes' theorem? How can we use Bayes' theorem in real time? And what is the statement and what is the formula and how to compute this Bayes' theorem? All these things we are going to discuss in this lecture. So, coming to the Bayes' theorem. So, Bayes' theorem was named after the mathematician that Thomas Bayes. So, this theorem was named after this mathematician Thomas Bayes, and mainly this Bayes' theorem is based upon conditional probability. So, the basis for this Bayes' theorem is conditional probability. In the previous lecture, we understood what is a conditional probability. Conditional probability means that occurrence of an event in relation to the happening of another event. A particular event happens if and only if one event happens or in connection with the other event. So, in such a case, the probability is called as conditional probability. So, this is the basis for Bayes' theorem. So, using Bayes' theorem, we are going to compute this conditional probability. So, conditional probability means where, say for example, probability of A given B, that is the probability of A we are computing, which is technically called as conditional probability, given the condition that the event B has already occurred. In such a case, the probability of occurrence of the event A given B is called as conditional probability, and using Bayes' theorem, how we can calculate this conditional probability? That this conditional probability is equal to the product of likelihood of the event B given A, that is probability of B given A multiplied by its priori probability, that is probability of B, divided by total probability of the event B. So, using this formula, we can calculate the conditional probability using Bayes' theorem. Bayes' theorem is used even for n events also. That is, for example, there are different n events like E1, E2, E3, so on En events which forms the sample space. All these E1, E2, E3 and so on En are disjoint events of the sample space S with non-zero probability. That is, every event will happen, certainly will happen. So, therefore, their probability is not going to be 0, and they form partition of the sample space S. And let us consider an event A, any event A which occurs in connection with these events E1, E2 and En. In such a case, how can we calculate probability using Bayes' theorem? So, normally Bayes' theorem is called revised theorem, because so initially we might be having P of E1, that is probability of occurrence of event E1, P of E2, probability of occurrence of E2 and so on, and probability of occurrence of an event A in connection with probability of the event EI or E1, E2, we can calculate. So, this Bayes' theorem comes into picture when a new evidence is added to the phenomenon. What is that new evidence? That is, if there is an event A where the event A has already occurred, and what is the probability for the occurrence of EI given that A has already occurred. So, a new evidence we are going to add here that A has already occurred, and what is the probability of this event. So, we are going to revise this priori probability, that is P of E1, or we can also call it in general terms P of EI. So, we are going to, by adding a new evidence to the new data to the existing probability, we are going to compute the revise the existing priori probability. That is why it is also called revised probability. So, this kind of probability we call it as posterior probability, whereas it is called P of E1 is called priori probability. Because what is priori probability? So, where based upon the historical data we can calculate the chance of occurrence of an event prior to the happening of the event. But whereas this P of EI given A, it is called posterior, because we are adding some new data, and based upon the historical data, to the historical data new evidence we are going to add, and we are going to revise this priori probability. That is why it is called posterior probability. So, by using this Bayes theorem, this is how we can calculate posterior probabilities, that when a new evidence is added to the existing phenomena, what is the chance of occurrence of an event, we can calculate using this Bayes theorem. So, coming to application part of this Bayes theorem, we can apply, we can use this Bayes theorem in all these different areas. Say for example, if we consider mailing system. So, normally we used to receive, an individual used to receive number of emails. So, we used to, one may be interested in knowing whether the mail is a spam mail or whether it is legitimate mail. How can we understand? And such kind of classification, whether a mail is spam mail or non-spam mail, such classification we are getting automatically. And how we can able to make such kind of classification that a mail as spam mail or non-spam mail? The background, the basis for such classification is nothing but this Bayes theorem. So, Bayes theorem helps us in classifying the mails. So, how this Bayes theorem classifies a mail as spam or non-spam using Bayes theorem? That is, so normally based upon certain words like offer or a discount. So, there might be some keywords which we come across in spam mails. So, this Bayes theorem, it calculates using the historical data, it calculates what is the probability of that a mail is going to be a spam mail if it has keywords like discount, offer and all. Okay. So, after having those probabilities, then the based upon the information, when a mail is received by a person, based upon this probability, it is, and this information, it is going to calculate whether if a mail is obtained, what is the probability that it is a spam or non-spam, based upon the probability that a mail which consists of discount is a spam mail. The probability that if a mail is having offer kind of keyword, it is going to be a spam mail. So, based upon this probability, it is going to classify when a mail is received with a particular keyword, what is the probability that it is a spam mail. So, this is how in real time we can make use of this Bayes theorem in filtering the mails as spam and non-spam. Likewise, even in weather forecasting also we can make use of this Bayes theorem. So, that is, for example, so we will be having different kinds of weather conditions. For example, so we can calculate probability of a day being a rainy day, and probability of that a day is a cloudy day. So, and we can have, if a day is a cloudy day, what is the probability of that day is going to be a rainy day. So, this is how we can calculate or predict whether a day which is a cloudy, whether it is going to rain or not. So, that is how even in case of weather forecasting also we can make use of this Bayes theorem. And also in drug testing, even in healthcare industry also, we can make use of this Bayes theorem. For example, if there is a new drug, so what is the probability of getting side effect when a new drug is injected to a particular person, where we might be having the probability of getting a side disease when a new drug is given to a patient. Okay, so in such a case also, even in healthcare industry, when normally doctor diagnoses a particular disease, and what is the probability of having positive test? If a patient is having diagnosed with a particular disease, what is the probability of having positive test report? So though sometimes though a patient is having a particular disease, it doesn't mean that he is going to have positive test result. So if a patient is having a disease, what is the probability of having positive test result or negative test result? So that is how even in healthcare industry we can make use of this Bayes theorem. And coming to let us try to understand how this Bayes theorem we can compute using this Bayes theorem, how we can make predictions, how we can calculate probability of occurrence of particular event in relation to the happening of another event. We can see here with this example that there is imagine that there is a person who is planning for his family picnic, and we are given that the chance of a day being a rainy day is 15%. We are also given that the chance of a day being a cloudy day, it is 25%. That is, there are 25% chances that if we consider randomly a day as a cloudy day, that day is going to be a cloudy day, the chances are 25%. 15% means 15% chances are that a day could be a rainy day. So this is the data we are given, and in addition to this, we are also given that there is 80% chances. Suppose if we consider a rainy day, the probability of that rainy day being a cloudy day is 80% chances. So this is the data given, and based upon this data, now so the individual is in dilemma whether to postpone the picnic or not to postpone, when the day, since the day of picnic is a cloudy day. Now what is given here? The day is a cloudy day, that is given, and based upon the calculation of this conditional probability, he can find out whether if a day is a cloudy day, what is the probability that day is going to be a rainy day. Based upon this chance factor, this conditional probability, he can make decision regarding whether to postpone the picnic or not to postpone the picnic. So therefore he has to find out this conditional probability. So for this we are given the formula given by this Bayes theorem is probability of cloudy day into a day, if a rainy day, if we consider a rainy day, the chance that day is going to be a cloudy day, divided by P of C. And if we substitute all these values in this formula, we are going to get 48%. This is called 48%. It means that there are 48% chances if if a day is cloudy day, it is going to be a rainy day, and the chances for that is 48%. But initially, if we look at the chances of a day being a rainy day, it is just only 15%. Now we have added a new evidence. What is that new evidence we have added? That is, the day is a cloudy day. So if a day is a cloudy day, what is the probability of raining? So here there is no such kind of new evidence. Here we have that if a day is a rainy day, the probability of it could be a cloudy day is 80%. But here, so the person wants to go for a picnic and he wants to postpone or not to postpone his picnic if the day is a rainy day. So he don't know whether it is going to be rainy day or not, but he has information that it is a cloudy day. Okay, so that is the new evidence which we have added to the hypothesis. What is the hypothesis? The probability of occurrence of an event, the possibilities of occurrence of a particular outcome, that is raining. Okay, so this is how, by adding new evidence to the hypothesis to existing data, we can calculate the revised probability. So initially the day is to be a rainy day, it is only 15% chances are there that to be a rainy day. But after adding new evidence that the day is a cloudy day, now what is the revised probability? It is changed from 15% to 48%. So therefore 48% chances are there that a day to be a rainy day if it is a cloudy day. So this is how we can update the existing probabilities, existing priori probabilities, by adding a new evidence. This is how we can make use of Bayes' theorem in real time. And so let us consider a case of more than 2 events. So imagine that there are 3 urns. So one urn is having 3 white, first urn is having 3 white, 2 black balls, second urn is having 2 white and 3 black balls, third urn is having 4 white and 1 black balls. So there are 3 urns altogether, E1, E2, E3, and there is an event to be happen. So without any biasing, one urn is chosen. From that one urn, one ball is going to be chosen at random, and which is a white ball. So what is happening here? So we are given information that there are 3 urns, U1, U2, U3. We are calling them as E1, E2, event E1, E2, E3. So probability of selecting first urn is as E1, probability of selecting second urn as the event E2, probability of selecting the third urn we have denoted it as event E3. So probability of selecting any urn is 1 by 3. Since, so probability of selecting first urn, probability of selecting second urn, probability of selecting third urn. So probability of selecting first urn, total there are 3 urns, there is only one favorable event for selecting first urn, therefore it is 1 by 3. Probability of E2, that is total number of urns 3, there is only one second urn which is having 2 white balls, 3 black balls, that is only 1 by 3. Likewise P of E3 is also 1 by 3. So this is the information initially we are given. And so let us define another event A. Event A as selecting randomly a white ball, that is one event. And we are given that if this white ball is chosen, before selecting this white ball, we have to select the urn. So we have the probabilities, conditional probabilities, that if a person selects first urn, and from the first urn, after selecting the first urn, if he randomly chooses one ball, probability of that ball being a white ball is 3 by 5. Since first we have selected first urn, so first urn is having total 5 balls. P of A given E1. So we have selected probability of A given E1 means E1 has already occurred. E1 means probability of selecting the first urn, and probability of A given in E1 is a conditional probability of the event A. So probability of a white ball from first urn. So first urn, total how many balls are there in the first urn? 5 balls. So event A is selecting one white ball. But How many white balls are there in the first urn? That is 3. So 3 favorable events are there for being a white ball, 3. So therefore probability of A given E1 is 3/5. Likewise, P of A given E2. So, if second urn is chosen, after selecting the second urn, if a white ball is selected at random, and what is the probability of that white ball? That ball is being a white ball which is selected from second urn. In the second urn also there are 5 balls, therefore, and favorable number of cases that ball is to be a white ball from the second urn is there are 2 white balls, therefore P of A given E2 is 2/5. Likewise, P of A given E3, that is if third urn is chosen, and after selecting the third urn, if a ball is selected from the third urn, that is going to be a white ball is 4/5. So, this is the information actually we have at hand. That is probability of occurrence of different events we have along with their priori probabilities and conditional probabilities. Now, here we know that there is the probability of selecting a ball from a particular urn is 33%. So, now what is the information we have? What is the hypothesis we have? A white ball can be the chance of selecting a white ball from urn 1, urn 2, urn 3 is 33% chances. This is the evidence, this is the hypothesis we have. Now, what is we are asked to find out is in this problem. So, what is the probability that it came from third urn? That is, if a ball is selected, what is that ball? That if a white ball is selected, already we have one event has already happened. What is that event? Randomly a ball is selected and that is found to be a white ball. And what is the new evidence we are adding? If a white ball is picked randomly if a ball is selected and that is a white ball, that is the evidence we have. And now, if we are going to add this new evidence to the existing data, now what is the probability that it is from third urn? This is what we are asked to find out. That is P of E3 given A, we are asked to find out. And the formula to find out this is P of A into P of E3 into P of A given E3, because initially urn was selected. And now let us see how to compute the required conditional probability using Bayes' theorem. That is, we are asked to find out one event has already occurred, that is a ball is selected at random which is a white ball. We have defined that event as A. So, this event A has already occurred, and what is that white ball? What is the probability of that white ball coming from third urn? This is the probability we are asked to find out, and the formula is given as P of A given E3 multiplied by priori probability P of E3 summation I running from 1 to 3 P of A given EI into P of EI. So, if we substitute all these values in this formula, we are going to obtain the final answer as 4/9, where that is the chance of occurrence is it is going to be 44.4%. So, initially what is the information we have? A ball to come from any urn, a ball to come, the white ball being coming from E1 or the white ball coming from E3 is 33%. P of E3 is 33%. Okay, but if we select a ball, white ball, the probability of getting that white ball from E3, it is going to be 44%. So this is how we can revise the existing probabilities. By adding new evidence, we can revise the existing probabilities using Bayes' theorem. Next, coming to let me conclude whatever we have learnt upon the theorems of probability. So altogether we have three theorems of probability, that is addition theorem, multiplication theorem and Bayes theorem. And addition theorem, where we use addition theorem? When we are dealing with mutually exclusive events. That is, when an event happens, the other event does not happen, only one event happens if the events are disjoint events. Okay, so addition theorem we can use when the events are mutually exclusive events, or when the case of mutually or non-mutually exclusive events comes into picture, then you have to use addition theorem. And multiplication theorem. So multiplication theorem can be used when the event can be classified into dependent and independent events, whereas addition theorem, when the events are classified as mutually exclusive or non-mutually exclusive events, then we can use addition theorem when the events are dependent and independent events. What is a dependent event? That the happening of one event is linked with the happening of another event, that is, the other event happens, then only a particular event happens. So in such a case, the event is said to be dependent events. So when there is a classification of dependent and independent events, then multiplication theorem comes into picture. And the other one, third theorem of probability is Bayes theorem, which is also called naive Bayes theorem, and which is most useful in case of medical health care, and in case of classifying whether the mails are spam or non-spam, even in forecasting the weather conditions. So in case of risk analysis, so there are several ways we can use Bayes theorem by adding a new evidence to the existing phenomenon, and we can revise the existing priori probabilities and we can make decisions accordingly. So finally, in this lecture we have understood what is a Bayes theorem and what is the formula, how to compute it, and what are the various applications in real time, how we can make use of this Bayes theorem for decision making. This is what we have understood in this present lecture. Thank you.